My name is Venkat Mahadevan, and I'm with the Advanced Research Computing team at UBC and also the Compute Canada Arbutus team and the Cloud National teams. So today, we'll just be looking at what we're doing for the upgrade of the West Cloud. Probably you guys know it better as West Cloud, but I'm going to be using nomenclature Arbutus Cloud more because that's kind of the name we're going with for the new system that's being created. All right. So we have quite a bit of time. I think this is scheduled to last until 11:30 Pacific. So what I will do is I'll go through my slides and a small demo that I have for you guys. And then after that, we can take questions. Some of the questions, I probably will have the answers to. Some I might not have the answers to. But whatever questions that you have, you can either type them in the chat window or you can ask me the questions directly. And we'll get you an answer either way. Maybe if it's a very complex one, maybe not in the time we have here, but we can take it offline as well. So feel free to ask any questions or express any concerns once we're done. So the presentation itself shouldn't take too long. The demo shouldn't take too long, so there'll be plenty of time for questions at the very end. All right. Hopefully you can all see the presentation that's popped up.
Looks good, Venkat.
Great. Thanks, Garth. So what we're doing right now over the next, I guess, month or so, the Arbutus team is working pretty hard to get the cloud expanded and upgraded so that it's a better fit for what you guys are doing with the cloud. And we have quite a few people already using the old service. So there's some changes that are coming up that you need to be aware of while we're moving towards the new service and some of the advantages and maybe a few disadvantages as well, but mostly I think the benefits are quite substantial by actually doing this upgrade. So I'll just run through a few things, all right? So Compute Canada Cloud Service, and this is fairly introductory. I think if you're using the cloud effectively already, you're probably already a fairly advanced user versus a traditional HPC user, i.e. you know how to set up instances, virtual machines, install images and so forth. So generally, the cloud is a good fit for apps that aren't a good fit for traditional HPC or non-cloud because it's pretty possible to create a huge infrastructure set very quickly. It's very configurable. There's availability. You can set up load balancing, some other things like that as well. So you really have quite a lot of control and flexibility with the cloud. And I think for users and applications that demand that, the cloud is a great platform to choose, all right? But if you're here, you already are using it in some fashion or the other. I just thought I'd give that blurb for people that probably are, if anyone wasn't using the cloud yet, all right? So currently, Compute Canada has 3 cloud deployments. So there's West Cloud, which I'm going to be calling Arbutus from now on, all right? And then there's East Cloud, and there's Graham Cloud. So East Cloud is at the University of Sherbrooke in Quebec. Graham Cloud is at Waterloo, where the Graham supercomputer is. And the Arbutus Cloud, or the old name West Cloud, is at the University of Victoria. So these are the 3 cloud deployments currently. Some more may be coming, but if you want to see what the specs are, how many cores, how much memory, et cetera, each cloud has, you can check out the wiki, and the link is at the docs.computecanada.ca. It'll give you a list of what's available. All right? So the Arbutus Cloud, right now, the Arbutus team is working really hard to do a pretty significant upgrade to increase capacity in various areas. And the reason why they're doing this is more and more people want to get involved with using the cloud, and there's more need for storage, more need for compute, and so forth. So there is demand for it as well, but it's also demand for better performance. So a couple of important reasons for why this upgrade is actually taking place. So currently, Arbutus consists of 7,640 compute cores, and those are spread across 290 physical nodes. 500 terabytes of persistent storage, and the storage backend is the Ceph platform, 78 terabytes of physical RAM, and there's 10 gigabit Ethernet connecting all the nodes and the storage in the cloud. All right, so even right now it has a fairly high capacity. This upgrade will increase the capacity even further. All right. So a lot of people are making use of the Arbutus Cloud. There are 320 projects, and when I say project, a project may be either a personal project that one of you might have requested just to do some prototyping, or it might be a resource allocation that your PI applied for to actually set up a fairly large piece of infrastructure or a research platform in the cloud. So quite a few. So 320 distinct projects running on the cloud, and hundreds of users actually using it, and perhaps even more users that are actually connecting to those VMs and accessing the data and services available on the cloud right now. So various workloads. I'm not even 100% sure what people are doing, because the cloud is so flexible, you can really do anything you want with it. So it's pretty good to see that there's quite a big uptake in the usage. So one of the issues with that, of course, is demand for the cloud resources is increasing. So as the platform matures and there's more use cases and more client-side tools for adding features and capabilities to it, the users come up with all sorts of new and cool, interesting things, and that, of course, needs more horsepower, storage, RAM, etc., etc. All right. So the first step of what the Arbutus team is doing is they're doing a hardware upgrade. So the aggregate new Arbutus Cloud will have 9,048 compute cores spread across 334 nodes. Storage is getting a pretty big upgrade, so 5.3 petabytes of raw storage. In terms of usable storage, the minimum will be around 2 petabytes, probably more, so between 2 to 4 petabytes. That just depends on the amount of redundancy and fail-safes that are put into the storage. And RAM is being increased to 91 terabytes. So that would be, as a core equivalent, about 10 gigabytes per core. So fairly substantial upgrade. If you look at it this way, this is a cloud system, but this itself, the amount of hardware that's being put in, would be a fairly large HPC system if you were thinking about it in an HPC context. Another thing that's been done is hyper-threading has been enabled on CPUs. So there are 2 hardware threads per core, so double the virtual CPU count. So this is pretty good, because now 1-to-1 vCPU to physical ratio, really high performance on compute applications. So if you select a C flavor, there are 2 types of flavors you can run even on the current cloud, but also on the future cloud, which are compute flavors and persistent flavors. So now if you select a compute flavor for your virtual machine or your instance, you get a 1-to-1 mapping of a virtual CPU to a physical thread, hardware thread on the core. So really high compute performance for compute applications. If you're running persistent apps that don't need that type of compute, kind of like maybe a website or some sort of database server, the ratio is 10-to-1, which is still pretty good for a cloud platform. That gives us the ability to run 640 vCPUs per persistent node. So there's pretty large legroom in the new cloud. All right. So the new nodes, added a bunch of new nodes. So these all have the latest Intel CPUs, fast disk drives, et cetera, et cetera. So there are a bunch of general purpose nodes with 256 gigabytes of RAM and SAS drives. So these nodes are generally for the compute nodes or the C flavors that you'll be running for a heavy computation. There are also persistent nodes which have more memory and SAS drives. And finally, we also have some SSD nodes which have fast SSD disks for applications that require very high I/O. So potentially there could be SSD flavors as well. We're still working out some of the logistics of that. But if you have an application that requires high I/O throughput to disk, SSD nodes could come in pretty handy for that. All right. So that's all about the hardware upgrade. So there's quite a lot of new hardware going in to aggregate and increase the capacity of the existing cloud to something new. But the other second and equally important piece of what's being done is software upgrade. So as probably some of you know, if you've been using this quite extensively, is that the cloud platform is actually built on something called Openstack. So Openstack is one of the most popular open source platforms for deploying clouds, so either private or public clouds. It's got thousands and thousands of users and platforms already deployed. They have like worldwide conferences and stuff. In fact, the most recent OpenStack user conference, the international one, is actually held at the Vancouver Convention Center in July. So it has a huge user base, huge support from a lot of hardware and software vendors. So I can name some of the companies supporting it. They have Lenovo, Google, Huawei, et cetera, Dell. So they have a huge amount of push behind it. So it's not going away anytime soon. So that's pretty good. And patches and new features are always being released. So the current West Cloud was running a fairly older version of Openstack. And this version, yeah, it worked pretty well for a while, but there's a new version now that's come out. It's called Openstack Queens, the Queens release, which has a bunch of user improvements. And I think one of the significant ones, I'll run through a few, is the actual user experience is a lot better. So the GUI, the Horizon interface that you log into when you look at your VMs, et cetera, it's a lot more stable, a lot more responsive. It's a lot cleaner. So definitely once you log into the new cloud, you'll actually see, wow, this actually works a lot better, even from just the perspective of management of your VMs and so forth, all right? But there's some other good stuff as well, not just at the front end, but at the back end. I'll just run through a few of those features that they've added to it. So several key features. I already talked about the improved user interface, so the instance creation wizard. So that interface is called Horizon, and I have some screenshots of that. And hopefully our connection is stable. I can show you also an interactive version of that as well. The second thing they've added is something called NUMA-aware compute flavors. So NUMA, I'm not sure how many of you are familiar with it, but the gist of NUMA is that NUMA lets you divide a compute node into blocks where cores access different banks of memory. They call that local memory. But essentially what it does is when you have a compute flavor, it'll optimize the scheduling of your VMs to run on the cores that have the fastest access to the memory available to those cores. So if you have any memory-intensive applications that need compute power as well, the system will automatically schedule them in the most optimal way, so you get very high throughput for memory bandwidth, which is kind of a nice thing if your applications are swapping a lot of info from CPU to RAM. The second thing is, of course, performance improvements, so improvements in the hypervisors, improvements in the general scheduling, like with the NUMA I mentioned. The other nice thing that they have now is volume attachment to multiple instances. So if you create a volume with some data, you can actually share that across multiple instances versus setting up something like an NFS server and so forth. The other thing is there's a lot of stability improvements to volume attachments. With the old release, occasionally you'd have issues like you couldn't detach a volume from a running instance or even a shutdown instance, or sometimes there might be glitches with deleting a volume. So for the most part, that stuff has been fixed, so it's a lot more stable, a lot cleaner, and definitely have more confidence in the use of the cloud, all right? So what does that mean in terms of, always one can say that, hey, previous system was working fine, just add more RAM, disk, et cetera, to the system. But one of the important reasons for actually doing this software upgrade is it lets us keep up to date with what the OpenStack Foundation is doing, because as we start falling behind releases, you stop getting security patches, you stop getting feature upgrades and so forth. So keeping in sync with the release cycle of what the OpenStack Foundation is putting out, and there's huge upgrades and changes all the time. Second thing is continuous improvement. So testing new features, installing new modules, etc., having an environment. So we have a development environment now where we can test new features and rush them into the production environment as needed versus not being able to do that with the current setup that we have. So it'll mean new features can come in as they become available, which is kind of nice. All right. Other thing that's also being done is an internal monitoring infrastructure. So the Arbutus team is putting a monitoring and alerting infrastructure in place. So let's say if there's a problem with the hypervisor or a node goes down and it's taken down some VMs with it, we'll be alerted faster to any of the issues and can bring those services back up versus waiting for a ticket or some other monitoring system to tell us something's going wrong. So the response time and hence the reliability is improved significantly. And finally, a couple of new availability zones have been added. So compute zones and persistent zones. So compute zones will be scheduled like the compute flavors on the VMs that are dedicated, sorry, not the VMs, the hosts, the hardware nodes that are dedicated to compute, and the persistent ones will be scheduled the ones that are dedicated to persistence. So just a little bit of a cleaner delineation between what the persistent cloud is and what the compute cloud is. I mean, you can always use both, but it's important to remember, compute cloud, you want high performance for compute memory intensive applications, use the C flavors to get scheduled optimally on the compute nodes. And for the persistent ones, they're scheduled on bigger nodes with a higher ratio of allocation, but generally persistent applications, like running a WordPress site or something, it doesn't usually need huge amounts of compute, and that's why you're having it in a persistent host, all right? So I'm going to try to do a demo. I'm connected via VPN to the Arbutus Cloud. So let me know if anything, you can't see anything or it glitches out of it. So far, things seem to be pretty stable. But I'll just go through a few points. The URL to access the Arbutus Cloud, it's going to be arbutus.cloud.computecanada.ca. So if you go there right now, it says coming soon. So yes, the production one is still not active yet, but just make a note of that URL. The old URL that you're used to actually using, west.cloud.computecanada.ca, that's actually being decommissioned. So we'll go through the timelines and some other things later. Like, don't worry about anything today. Like, as of today, keep using your old VMs and your instances and doing whatever you do normally with the cloud. There's no change as of today. So it's not going to be turned off right after this or anything like that. So don't worry about that. You'll have significant notice to actually determine what you need to do. The other caveat is Firefox and Chrome are supported. Safari is not supported. You can try, but I've noticed there have always been some glitches with Horizon and Safari. So I'm going to go through just an example of creating a new instance and the migration steps. Some of this is fairly basic, but for the benefit of people that haven't used this and just are interested in seeing how it looks, just bear with me. All right, so this is a screenshot of how the new instance creation wizard looks like. So it looks fairly different, but a lot of the concepts and ideas are the same as what you've been used to when you create instances on the West Cloud, all right? So you set up an instance name, a description. You can choose between availability zones. There's Nova, which is a general zone. There's also the compute and the persistent zones I mentioned, or any availability zone where you can let the system determine where to place your VMs. Second thing, screen, of course, standard is what's your boot source. So it can either be an image and create a new volume for persistent data, or you don't need that. You can use the ephemeral storage as well. And you can select various types of images. So the ones that are available on West Cloud, CentOS, Ubuntu, et cetera, those will be made available on the new one as well. So that stuff will be matched up so you're not taken by surprise. So those will all be named the same and so forth. And then you have flavors as well. So same thing as before in the West Cloud. You have the C flavors which are dedicated towards computational purposes, which have ephemeral disk. And you have the P flavors, which are more for the persistent type. So if you're developing research platforms and portals versus doing computation on the cloud, you probably go with the P flavor with persistent disk and persistent storage versus a C flavor, which is more for just compute. All right. Networks, you will have your own subnets and a private IP address space for your VMs within your projects, same as before. And of course, floating IPs for external access to your VMs, all right? And same thing as before, there are security groups, and with these security groups, you can manage the rules. So you can allow things like which IPs are allowed to SSH into my VMs, who's allowed to connect to my VMs via HTTP, or whatever protocol you decide, you can set them up the same way as before with your security groups. And finally, you have key pairs as well, just like before, where you can set up SSH private public key pair for logging into your VM, assuming it's a Linux VM. You can just SSH in using the key pair, and you can import your current ones as well, whatever you have on the West Cloud. If you have all these keys already set up, you can just import the ones you already have instead of creating new ones, just to keep it simple, all right? So that's an example of the instance creation wizard. I'll talk a little bit about migration, then I'll turn PowerPoint off for a little bit and just move towards my Chrome browser just to show you some of the things, some of the migration testing that we've done, all right? So one of the questions I think that could be commonly asked is, why is there actually a migration process, right? Why can't you just say, okay, kind of like when you upgrade an application or some sort of piece of server software, just upgrade it in place and say, hey, you know, after X and Y date, everything will be available in the new system. There's no need to migrate. You know, there is some possibility to actually do that, but given the complexity of the system, there are a couple of caveats and pretty big ones, risk factors associated with doing an in-place upgrade. One thing is there's a lot of stuff already running on the cloud that needs some certain uptime. So if an in-place upgrade is attempted, there would be a fairly long outage window while this upgrade is being done. So networks that we recreated, the entire cloud infrastructure that we recreated, the data would have be copied over and so forth. And no guarantees at the end of all that it would actually work, because some releases are behind. There could be compatibility problems between various releases and so forth. So in interest of keeping the user data safe, this migration process is proposed as probably the best practice when moving to a new version of OpenStack. If you do read most of the literature around there, whether it's the OpenStack Foundation literature or other providers like IBM, Lenovo, etc., that this approach is recommended more than doing an in-place upgrade, because in-place upgrade is a risky process and would have quite a large outage window. Whereas with the current setup, you can technically kind of get away with having either a very small outage or no outage at all. Yes, it's a little bit more work, but it makes you more confident in the integrity and safety of the data that you have in the cloud. And it also gives more control to the user what they want to do with their VMs going forward, all right? So the approach that we're taking is both the clouds will exist simultaneously. So the old West Cloud will be available, and the new Arbutus Cloud will be available simultaneously. Simultaneously, the uptime will be there. And when both these clouds are available, you can then schedule the migrations on your own time, on your own schedule, and copy the data, etc., so forth, versus waiting for like a long outage period where everything is down and then brought back up. So there are a lot of positives to the improved performance of the software, improved performance of the hardware. The migration, yes, it's a little bit of work. I'm not going to say it's the most straightforward thing, but we're going to be providing lots of documentation how to do it. We definitely felt this was a better process for the users as well, simply because it guarantees, there's more guarantees in terms of the safety of the data and whatever has been done versus doing an in-place upgrade. So there's always pros and cons, but you can see if you read the literature, as I mentioned earlier, the migration process when moving between versions is kind of considered best practice, all right? So the general high-level steps for actually performing a migration is, first thing you do is you'd log into the new cloud dashboard or the command line interface. So if you're a basic cloud user, you probably just use Horizon and you do a bunch of stuff there. If you're an advanced user that set up things using deployment tools like Ansible or Terraform, things like that, you probably are familiar with the command line interface and can do some stuff. Even if you're not, don't worry, because we'll have all the commands available on the FAQ for the migration, and you can copy and paste and run through kind of like a cookbook of how to do the migration. So we won't leave people to figure out the process on their own. We'll have certain steps, and we'll be able to assist with every step along the way, all right? So the general steps are, log into the new cloud dashboard or the command line interface, copy the existing images. So you can take existing images from the West Cloud and copy them over to the new Arbutus Cloud and create new VMs based on that. Or if you're just using compute flavors, you can just create new base images and just run from there if you have it scripted. Then install and configure any services if you're not using a pre-created image. You can use tools like Ansible and so forth. If you have very large volumes, like we're going to kind of determine what the optimal threshold is, but I'd say anything over 20 gigabytes, there should be a different process versus creating an image and copying the image over, just for performance reasons. So we'll have some information on that as well, how to do large migrations if your allocation is very large. In most cases, you should just be able to copy existing images over. I think that should apply to most users. If you're running persistent stuff and you have a DNS server, so the floating IPs on the new cloud will change for the most part, and then you have to do a DNS update. If you can't afford to have that change, just get in touch with us, via the usual support channels, and we can work something out there as well. But generally, the persistent floating IPs will change. Then finally, once you're done and you're satisfied that your stuff is working on the new cloud, you've done your validation, your unit tests, and so forth, the old instances can be decommissioned and the volumes can be deleted on the old cloud. So these are the general high-level steps. There are more nuanced steps that will be available, and I'll show you a little bit of some of the migration that I did from the old cloud to the new cloud right after this. But this is the high-level overview of what needs to be done to perform a migration, all right? So there are three general scenarios for migration. I'd say the first one is probably the easiest one. If you have a very small number of VMs or you have some automated way of provisioning VMs in OpenStack, you could just deploy the new virtual infrastructure right on the new cloud, copy some data over, configure it, and boom, you're done. So this probably makes a lot of sense for people that are doing compute-only stuff on the West Cloud. So if you're just doing compute stuff without any sort of persistent data, just create the new infrastructure again. Don't even worry about what's on the old stuff, and just run with it. And that's probably the simplest scenario for that use case. The other use case is also their image-backed instances, right? So in that case, you want to copy over the ephemeral data, either by creating an image of that image and copying that image over, or copying the data in some other fashion, all right? The other way is a volume-backed instance. So these are for the persistent instances. Probably the more complex migration that you would have to do is create an image of that volume, move that image across to the clouds, and then create an instance based to boot from that volume, all right? Because you can create a new instance. And that's probably the example I will show you is the third one, just to show that it actually works. So the various methods will be documented on the migration wiki, and there's a link at the last slide, how to actually perform a migration based on the scenario. I think advanced users shouldn't have too many issues. If you're a more novice user and you're having troubles, of course, reach out. I think we'll always have operations staff available to help with the migrations. But I think it follows more of a cookbook approach, that there's a few pathways of how to do it and the best way to actually get it done. It's more a matter of timing when works best for you and the testing after the fact, all right? So tenants with a rack, so with a resource allocation. So if you're a PI or you're in a PI's lab and you have a resource allocation or a rapid access service allocation, these tenants will be pre-created in the new cloud. So you'll have the same project with the same quota, et cetera, created, the same user access. The remainder, so there are several, don't know how many yet, quite a lot of abandoned projects that aren't being used. So there'll be a determination of when the projects were last used based on the last login time, and these might or might not be migrated automatically. But if you find that, hey, I need this project created on the new cloud, you basically just send us a support email and we'll move it over for you. So you can't log into the new cloud with your Compute Canada credentials, and you need to, and you expect your project to actually be there, just let us know and we will make that happen. But people with a rack and a RAS, all those will be moved by default. I'm not saying the instances will be moved, but the actual tenant and the project themselves. The instances will still need to be migrated at the user level, all right? And last point to mention is if you have any sort of super important data, although the cloud has a lot of redundancy and resiliency for disk failure, so the storage system is highly available in that even if many disks fail, you won't lose data. There's no actual backup of cloud VMs. So make sure you actually back up any important data before deleting anything off the old cloud if you absolutely can't do without that data, all right? So I guess I'll switch over a little bit to the migration, but I'll just go over Keystone a little bit. So one of the big changes in this release is the Identity API version 3 has been released. So if you've been using the command line tools, generally you've probably been using the version 2 of the Identity API. So version 3 is backward compatible. So pretty much all the command line stuff you're doing should work right off the bat. There may be some exceptions that can be worked around, but it should work right away. One thing that you do need to do is you need to download a new OpenStack RC file. And you can get this from the Horizon web interface. I'll show you a little bit of a screen there how to get it. So Keystone version 3 is pretty nice, a whole bunch of new features, the command line clients. It's available for Mac, Windows, Linux, so whatever client platform you're using is supported. So if you want to get a new RC file when you get access to the new cloud, you can just go to the API access section and you can download the new RC file, either for the old APIs. The old API will still be available, but it's recommended to use the new version 3 API. You can download either of those and then you can start executing your commands. So if you have any scripts that are doing automatic deployment, Ansible, playbooks, et cetera, you can use this RC file, source it in your environment, and then do some automation. That should work. Whatever you have should work right off the bat. There may be some small exception cases, but it should be pretty straightforward. All right. So I guess I'll go through, an actual live bit of the GUIs. Just bear with me a second while I switch out from this presentation, and let me know if you can't see the browser. All right. So over here, I guess I'll just have to share it, sorry. Let's go back to video. Okay, so I hope everyone can see my Chrome window. If you can't see it, just let me know. You can just put a chat message over there. Great. So what you see on the left is probably fairly familiar to all of you guys. It's the old West Cloud GUI. So this shows the instances that I have running on West Cloud. So this is kind of familiar to what you guys have been doing, just a standard Horizon interface. I have three instances or VMs running over here, and I created one called Demo, and that's a really simple instance based on CentOS, and it's running Apache web server, just a blank web server. And I have a couple of other production VMs that are running there as well. So this web server, all it's doing is just serving up the standard default CentOS Apache page. But I want to show that you can take this web server and you can move it across to the other cloud, all right? So this is an image-backed instance. So not image, sorry, a volume-backed instance. So it has a volume. So this demo instance is hooked up to a volume in the backend. So you can see here there's a 10 gigabyte volume, and it says attached to demo on dev VDA, all right? So what I've done is I've pre-created an image based on this volume to move that image to the other cloud. But the way you would do it is you would go here and you would go upload to image. So when you go upload to image, you can create an image. I called it migrate. I already did that, so I won't do that again. But that can be used to create an image. And taking that image, you can move the whole instance across to the new cloud. So now if I go to images over here, I have an image called test migrate, and you can see it's the same size. It's a 10 gigabyte image. So now I have my image available. What I can do then is take this image and push it into the new cloud, all right? So this is my old cloud over here. Here's my new cloud, which is Arbutus, running the latest version of Openstack Queens, all right? So what you have to do to push the image across, there is a command that you execute. It uses the glance client. So you would use the glance client to first download the image to some staging area. That could be either one of our servers or it could be a local workstation that you have. You probably want to use something that has a pretty big fast network connection. I.e. don't do it on your Shaw at home connection because it's 10 gigabytes is still quite a lot. But if you're on any sort of campus connection, it should work fine. So you use glance to download that image from the old cloud and then upload that image to new cloud. That command will be provided for you on the migration wiki, but it's basically glance image download, image name. You download the image, then you push the image back up to the new cloud. So I've already done that over here in this new cloud. So you can see the image is already here, and I called it migration. It's the same image, it's 10 gigabytes. So based on this image that I've transferred between the two clouds, I can create a new instance. So I can go to my instances over here. Sorry, it's timed out my login. All right. So what I can do now is I can launch an instance, and I'll choose another persistent flavor as well. So I'll call that demo 2. And I'll create it in one of the persistent zones. So the boot source will be an image. In this case, just to save time, I won't create a new volume. So image, I can select the migration image that was transferred from the old cloud. All right. Now I can select the flavor. So I'll select one of the persistent flavors here. All right, so 4 CPUs, 6 gigabytes of memory. And for the network, I'll choose one of my subnets. Leave that blank. I'll use my default security group. And for my key pair, I'll use my demo key for SSH. All right. So that's pretty much it, and now I can launch that instance in the new cloud. So mind you, I'm showing this via the Horizon GUI. All this is also available via the backend using your OpenRC file and all your command line tools. So we'll also provide that information, how to do it using the command line tools. If you want to script it or you prefer running via the command line versus actually running versus this. If you have like lots and lots of instances, obviously it makes more sense to script it and run the commands versus creating. But if you have one or two, the GUI works just fine. All right. So now I have my instance created over here. I'm going to assign it floating IP. All right, so I can access it externally. Here's an IP address, public IP, and that's my demo instance I created just now. And I can associate that. All right, so the floating IP has now been associated. So now keep fingers crossed that when I actually go to this, it's going to bring up the same HTTP web server that I configured on the old one. Yeah, and definitely, as Mike says, it's a high-risk live demo. And usually when you're testing this at home or in the office, you're like, oh yeah, it works perfectly. I tested it 10 times. But because we're doing it today in the demo, the Heisenberg uncertainty principle comes into effect, and it's going to say, whoops, not going to work. But hopefully that doesn't happen. So let's actually see what happens here. Woo, that works. All right, so simple example of moving a web server from one cloud to another cloud, the old West Cloud, the new Arbutus Cloud, all right, associating a public IP address as working. So this is an example of a volume-backed instance being migrated. And the other two types, of course, the image-backed instance and the other one where you're just using computational nodes. And that's probably the easier one because just create new infrastructure. If you don't have any big data sets, you just copy some of those over by SCP. So various scenarios depending on your application. This was just an example of how to do a persistent node, a VM transfer from one cloud to another cloud. All right. So not too difficult, but there's a lot of nuances involved with it. All right. So I'll go back to PowerPoint because I have just a few more slides left, and then we can take the questions. I know Mike has been answering a bunch of questions in the chat channel. So you can either ask questions in the chat channel or you can ask them. I'll try my best to answer them. Okay, so Keystone version 3, we went through that. So the migration timeline, and these are the proposed dates for actually doing the migration. So the upgraded cloud, the new Arbutus production stable version will be available in October. So coming up fairly soon. So sometime in October, once all the units and validation tests have been passed, it's going to be available. So if you're a client and you have a tenant or a project on this old cloud, you'll be notified when the new cloud is available and when your project is created on the Arbutus and available for you to log in and use. So you'll receive a message from us saying, hey, your quota is available, it's created on the new cloud. Here's the migration link, go ahead and migrate, contact us if you have any issues and questions. So kind of like a staged process where we'll be contacting various people in a staggered order, all right? The second thing would be the legacy cloud shutdown. What that means is the old West Cloud, once we've determined that people are migrated off, it's proposed for January 2019. The access to the legacy cloud will be disabled. So if you try to log into the old west.cloud.computecanada.ca, you won't be able to log into that anymore. But the data, any data that's still left on the cloud, if you haven't migrated it for some reason, we'd still keep it available just in case you need it, and you can contact us to get access to it. And finally, the legacy cloud decommissioning. And this is where we actually delete the old data and actually take that storage and aggregate it back into the new cloud is proposed for February 2019. So these are the timelines, and definitely we want to support all the user and client base with your migration process. Hopefully make it as painless as possible to get you onto the new infrastructure. And that's definitely a goal here. So the migration FAQ is probably going to be your best friend in determining how to actually go about doing all these things. Right now, if you go there, it's still quite high level, but over the next couple of weeks or so, it's going to be fleshed out with a lot of very detailed information on migration and testing and so forth. So make sure you bookmark that. check it once you receive your notification that your resources are provisioned and ready for migration. And as always, we're definitely quite eager to help people start using the new infrastructure. So any sort of issues, the usual support channels available, cloud@computecanada.ca will create a ticket which will be assigned to our operations staff. So yeah, once the new cloud is actually available, you'll get a notification and you can go from there. So I think we're about 42 minutes past 10 Pacific. So I think I'll start taking questions and just looking at the chat channel. Sorry, I'm just losing my voice a little bit. So I'll just end the slide sharing for the moment. All right. All right. So I just looking at the chat, and there are quite a few questions. So I'm running here, and actually Mike has been answering a few already. So Mike has answered a few, and then okay. So the questions, it seems Mike has been hitting all the questions on the chat. Are there any questions that anyone wants to ask for everyone else to hear for the benefit as well? Or we continue with the chat as well, or we can even talk about it right now while we have Mike and myself over here. No, people prefer the chat. Any concerns, anything you want further clarification on? We're glad to hang around a bit and actually, but if you don't feel like asking, feel free to definitely send us a support request or an email to the usual channels, and we can work one-on-one with you, either your local support teams. If you're at the University of British Columbia, the ARC team over here can assist you one-on-one consultation. If you're at another university, I'm sure you have some support as well. Or you can send to the cloud address and we'll get back to you if you don't feel like asking the question on this forum. But I'll keep the things going because quite a little bit of chat has been going on the side. So I'll hang around a bit and I'll just wait for your questions.
Okay, so to answer questions about data migrations, I think, can you hear me now?
Oh yeah, perfect.
Okay, great. So in order to do data migrations, we know it's a lot of data. We know that some people have, there's projects with over 100 terabytes of data just on their own. We know that it's going to hopefully, we know that it's going to take a while. We understand that. The connections between the two clouds is a 10 gigabit connection, so it's as much data as we can stuff in there. We'll be able to do the migrations. And in a perfect world, we figured out that it should take 9 days of total time to rsync all of the data between the two clouds. That's 9 days at 10 gigabits. But we know that that's probably not going to happen. Small I/O and things like that makes things a little bit slower for data transfers. That's why we're giving quite a lot of time to get the data migrated over, a couple of months. It shouldn't be too big of a problem. If you need help or if we can facilitate in any way, then always reach out to us and we're more than happy to help guide the process along. We have no worries about allocation. So if your allocation on current West Cloud is, say, for 5 terabytes, your new allocation on Arbutus Cloud is going to be also for 5 terabytes, and we won't restrict you in either side. So any data you have currently hosted in West Cloud will have lots of room to move back over to Arbutus Cloud. So you shouldn't have any issues that way.
So the question about GPU from SF. So unfortunately, I probably have a negative on it for the moment. The upgrade hasn't purchased any additional GPUs. That is a plan, depending on obviously funding and other types of things. There's some older GPUs available, K-series GPUs available on the West Cloud, and those will be moved over. And the new release does have some capability to do something called vGPU. Just like you have vCPU, you have vGPU, where the cores of the GPU can also be allocated versus just the whole node. So definitely some testing will be done on that. But in terms of actual new current gen GPUs like Volta or Turing, which is coming, at the moment, no plans for that. But of course, that can change.
We're always interested in expanding the capabilities of the cloud, and so we are looking at that. We're also looking at a future expansion, hopefully, for actual HPC in the cloud. So, I mean, keep your ear to the ground. We'll make announcements and things as things come along, but that's all due to funding and time and resourcing and all that stuff. But yeah, we will be moving over the current GPU load, but that won't happen until likely the very last thing. We won't end up migrating the GPUs. But if you have a special request for GPUs, you can put in a ticket with us and we can hopefully help you.
So there's a question on the public IP, the floating IP. So the public IPs, the new cloud will have a new pool of IPs. So if you don't absolutely need to have your old IP, you can just grab a new IP from the new pool of IPs. So you don't have to shut down your old one. You can keep your old IP running on the West Cloud. But yes, if you do want that exact IP, you need to get in touch and we'd have to migrate that IP over. But if you don't care, it's just an IP and you have access to DNS, you could just change DNS. But yeah, unless you actually want that particular IP for whatever reason, then you will need to shut down on the old cloud and then move that IP over. But you can just grab one of the new IPs if you don't care about that particular IP.
Yeah, and the recommended way to do that is actually get your new instances running in the new cloud and update your DNS so that you actually have both addresses in your DNS, and then you make sure that your new instances are running fine, and then you remove the old IP address, and then you'll have no outage. So it allows for a much smoother migration if you're running a portal, and that should help out.
So just a few questions that have come up on the side. What's GPU? So GPU is graphics processing units. So some applications, so if you're a gamer, you probably know you have those graphics cards in your computer, NVIDIA or AMD. They have processors that are good for very particular type of scientific applications. So certain things like video coding or certain bioinformatics pipelines or astronomy applications, the graphics processing units can be used for computations that are much faster than a central processing unit. So if you have an application that can support GPU, it's definitely something that can be accelerated. The HPC is high performance computing. So somebody had a question what that is. That's the traditional compute cluster where you submit jobs in a batch format to the cluster. It runs the jobs and returns the results. So Compute Canada provides HPC as well at the various supercomputing sites. And there's some documentation on that too. But this is more, I guess, just the cloud. There's another question from SF. Any plan to support new Openstack services such as shared file system, Manila, or database as a service? So maybe, Mike, I can pass that on over to you.
Yeah, so we are looking at adding in the Manila service to the new installation, probably sometime after the migrations are complete. We'd like to have file system as a service, Manila, running, as well as we are looking at adding in, we have hardware for database as a service, and so we will be looking at an implementation of that as well. These will, unfortunately, we don't have time to develop them right now, so for launch, but they are services that will be brought online in the new year.
And the other question from Derek is best practice for backend databases with persistent web portals. So Mike, I might pass this on to you as well, but I have my own viewpoint on that one. Is I pretty much have persistent VMs running at some database server in the back end. I quiesce those from time to time and will take snapshots of the actual database data, like a MySQL dump or things like that, but put them on the private address space, make sure they're well protected with IP tables or packet filter, some firewall and so forth. That's kind of just my recommendations, not to expose the database. If you're running a portal, I generally will run the database server on a separate internal VM versus the front end and only allow access to a very restricted account on the portal to connect to that database. So those are my viewpoints on that. The other question was, can we request resource increases before we migrate? So the answer to that should be yes. You can request a resource. I mean, as long as you have some justification for it, sure, definitely take it into consideration. And finally, DL has one. Our tenant came in from the very early days of the cloud, and it's called Nephos, Persistent Compute VMs. Yeah, for sure. I think for this one, this might even be before my time. Definitely, let's have a chat about that.
Yeah, that one sounds interesting. I think what you'd probably want to do there is make images out of your instances so that you're not losing anything that way, and then run them, then migrate the images. That would probably be your best bet.
Yeah. And do you have any ideas on database stuff, Mike, or do you think I covered most of the things on the...
I think you're right on that. I think the database, that sounds like the best practice for us as well. Don't ever expose your database host to the internet. Only expose it to the service that requires it. If you're talking about what's the best practice for migrating them, you'll have to come up with a strategy for taking down the database and migrating the data and bringing it back up. We can talk about that if you need some help. But it should be fairly straightforward, the same as everything else. You may have to suffer an outage of your portal, though, while you migrate the data.
Yeah, and I think the outages, that schedule of the outages, the outages shouldn't be large outages. There might be cases where if there's a lot of disk access and other things, a shutdown might actually make the most sense, where you turn off the VM and then you make a snapshot or create an image of it, and then move that across just so that your data is consistent. There's also some file locking in the West Cloud where you sometimes have no choice but to do that. So there probably will be some small outages on a case-by-case basis as you move stuff, especially things with persistent data, and I think that can be determined. But it does give you the ability to schedule when you want that to happen versus, as I mentioned earlier, like an in-place upgrade would be the whole cloud unavailable for weeks at a time potentially. So I do expect there will be, depending on the apps, especially web portals and databases, that some sort of quiescing of the data would have to take place, creating the images and moving it. So some small outages, but hopefully it shouldn't take too long. The databases are extremely large. We should talk one-on-one about it. But if they're of a certain size, 20 to 30 gigabytes shouldn't be too bad. All right, so I'm just going to look through any more of these questions here. I don't see any new ones that have come up. I hope we answered most of the questions that people had. So there's a question about creation of flavors. So Mike, could you take that one?
Well, flavors will be providing predefined flavors for everybody. If you need a custom flavor, we can help you out with that, but we don't allow creating custom flavors by the users because we have to keep in mind the global picture of how resources are being divided up on various pieces of hardware. So it's nice to have flavors that go in 8-core increments, that kind of a thing, because our machines have 56 cores available on them, so we don't necessarily want to have machines that are sitting there idle with like odd numbers of cores that we can't schedule onto. So typically, if you need a specific flavor, then we'll need to work with you in order to get that provisioned. When you're looking at needing a lot of CPUs in a C flavor, if that flavor is going to end up taking up an entire compute node, then we really need to talk about that because scheduling will be very difficult for you. So we need to kind of do a bit of an analysis on what you're doing and figure out what the best use case is and how we can best provision that. So it comes down to some tweaking and customization, but we can make it work.
It's 11 hours.
Yeah. So I think just adding to the point Mike mentioned, things like NUMA scheduling and the way the nodes are actually configured, because hundreds of VMs are running at any given time. If, let's say, people created single core flavors with small amounts of RAM and so forth, you're subdividing the memory domains as well in a suboptimal fashion. So definitely, if some application needs it and actually fits within the overall strategy so there's good performance for everybody, it's definitely something that can be looked at. Yeah. Great. I think this is scheduled until 11:30, but obviously if there are no other questions, we can end early. But if you have any other questions, feel free to type them in or even ask them now. But I think a lot of the things will become apparent once the migration document is more fully fleshed out and actually published on how to do things. But I want to emphasize that we do appreciate the fact that you guys, are cooperating with doing the migration and helping us out with this, because we couldn't do it without you guys to actually assist in doing the migration to the new cloud. So we really appreciate that. And if there's any concerns or questions, the team is available to assist and help, because we don't want to make this a painful process, right? We want to get you on the new platform because we think you will enjoy using it and you'll have a much better experience. There's a little bit of upfront work to do that, but I think if we work together, we can get it done in a reasonable time frame. And I think the end result is better for everybody than what we currently have. I mean, what we currently have is not bad, but it has some glitches, and it'll be nice to move on to something that's current and stable. I guess that's just in closing.
And something that we've got going on here too. So normally for Arbutus or for West Cloud operations, we usually have one person monitoring the ticket queue and answering questions and making sure that things are being moved along. Once we launch the new cloud, we'll be putting our entire operations team on continuous operations. So for the migration period, we will likely have 6 or 7 people watching the queue all the time and helping triage any issues that people come up against. So you'll have, hopefully very responsive help, lots of interaction with all of us on the operations team, and just making sure that this is as smooth as possible. We don't want anybody to feel like they're being left out or that they have to figure it all out on their own. We know that this can be complicated and not everybody is a systems administrator. So we want to make sure that, we're here for support, and we can, definitely work with everybody to get everything sorted out and moved over. We've got something like, I think, Venkat, is there 400 projects right now in West Cloud?
Oh yeah, I think so. I think the thing that I had with 320, it's probably gone up to 400 by now. Yeah, so quite a few.
Yeah, and so because of that, we know that there's going to be a lot of questions, and we don't mind. It's why we're here, and we just want to make this the best experience that we can, and to ensure that everybody's getting out of the cloud what they need, as well as, listening for improvements, and if there's any bugs or any issues, we want to know right away.
And just answering Doug's question, do you want to get in touch for special things? I think, yeah, sure, go ahead and let us know. Get in touch with us and tell us what you're up to, and it can all be done, in parallel. Like, we have a bunch of stuff to do on this end that we're getting ready in prep for the launch, but definitely we'll have it. Might not be able to give you an answer right away while things are still being determined, but if you have any particular special case you think is interesting or might cause issues, feel free to reach out.
And so, as Venkat said, we're going to be kind of letting you know when your project is ready for migration. That would be the perfect time to come and say, hey, I've got a couple of special requests, or here's a couple of things that I need to look at. It'll keep everything very well scoped, and we won't drop your request on the floor. We'll be dealing with a lot of different projects. So once we email you and say, hey, it's time to move your project, or you can move your project anytime now, that's the time to kind of formulate out all your questions, send them along in a ticket, and then we can deal with them in line with each move. The hope is that the cloud is ready for the first week of October, and we'll start migrations in early October. We're still, of course, new platform, new bugs, so we're working through them, and we will let you know, essentially.
Yeah, Amber had a good question about OwnCloud. So no impact on OwnCloud. OwnCloud's running on a completely separate site, separate hardware, separate software. So feel free to continue using OwnCloud. There's no changes. That service will evolve on its own time frame, but no impact from this. Great. Maybe I'll wait for one more minute. And then just to see if there's any questions at the end that people come up with. But if nothing comes then, just want to thank you guys all in advance for taking the time out of the morning schedule to actually attend this presentation. And let's keep it an ongoing conversation normal support channels, or even reach out to us if you know us locally, and we'll try to get this all done for you as smoothly and quickly as possible. And we really appreciate you guys taking the time out. Once again, thank you.